Hi, everybody. We've reached the last section in Chapter 9 that we're going to cover, which is 9.4 on hypothesis testing for proportion of a population. So remember in the last two sections, we were testing claims about a population mean. So now we're going to be testing claims about a population proportion. All right, so proportion data follow the binomial distribution, which can be approximated by the normal distribution, remember, if n times p and n times 1 minus p are both at least 5. And again, n is the sample size and p is the probability of a success in the population. All right, so one of the first things we'll need when we test a claim about a population proportion is the sample proportion. So you find that using this formula. Remember, we call the sample proportion P bar. P bar is just X divided by N, where X is the number of observations of interest in the sample, and N is the sample size. And then the formula for the z-test statistic for a hypothesis test for the proportion, you see it right here. They call it z sub p, and it's p bar minus p sub h0 divided by the standard error of the proportion under the null hypothesis, which would be the square root of p sub h0 times 1 minus p sub h0 divided by n. So again, z sub p is the z-test statistic for the proportion, p bar is the sample proportion, and p sub h0 is the population proportion, assuming that the null hypothesis is true. And again, n is the sample size. All right, so for example, the proportion of cell phone users with 4G contracts last year was p equals 0.62. A Verizon executive thinks the proportion has increased this year. Suppose that from a random sample of 350 users, 238 have 4G contracts. So we'll test the executive's claim using alpha equals 0.05. So as usual, first we'll identify our null and alternative hypotheses. The claim was that the proportion is now greater than 62%. Greater than makes it the alternative hypothesis. And that would mean that the null hypothesis is p is less than or equal to 0.62. In step 2, we'll set a value for the significance level alpha, and alpha equals 0.05 has already been chosen. All right, step 3, we'll determine the appropriate critical value. The binomial distribution can be approximated with the normal distribution. So we'll use z for this type of test. And as we've seen before, for a right tail test with alpha equals 0.05, the critical z-score is 1.645. And since this is a one-tail test, specifically a right tail test, the entire area for alpha equals 0.05 is placed on the right side of the sampling distribution, as you see in this picture. All right, so now we'll calculate our test statistic. First, we'll find our sample proportion. The sample proportion is x divided by n, which in this example is 238 divided by 350, which is 0.68. And our test statistic, using the formula that we talked about earlier, this is one that you should try with your calculator right now. 0.68 minus 0.62, and then divide by the square root of 0.62 times 1 minus 0.62 divided by 350. And that comes out to about 2.31. All right, so now we calculate we compare our test statistic with the critical z-score. For a one-tail upper tail test, you reject the null hypothesis if your calculated statistic comes out to be greater than your critical value. Since 2.31 is greater than 1.645, we will reject the null hypothesis, as you see in this picture. Remember, I'm not a fan of memorizing all those rules. that we saw a couple sections ago. Just draw the picture, draw your critical region, your rejection region, and see if your calculated test statistic comes out to be in that rejection region. So in this case, it does. Anything greater than 1.645, we will reject the null hypothesis. So our conclusion would be, at the 0.05 level of significance, the proportion of people with 4G contracts has increased above 62%. So the executive was correct. All right, and then if you're using the p-value approach instead of the critical value approach, that is identical to what we went over 2 sections ago, testing a claim about a mean where sigma is known, because in that case, again, you're using z. And again, the p-value shows the probability of obtaining a sample result at least as unusual or at least as extreme as the one observed in a world where the null hypothesis is true. So in the example we just did, the calculated test statistic is 2.31. So you can use table A2 to find that the probability that z is greater than 2.31 is about 0.0104. And remember, when p is low, the null must go. So since the p-value 0.0104 is less than 0.05, we reject the null hypothesis. All right, and then I'll end by just letting you look at this last slide. I don't really feel the need to use Excel for this type of problem because it's easy enough to use table A2. Unlike in the last section, when we were using a t test statistic, you can find exact p-values in the table. All right, so probably not necessary to use Excel, but there it is if you'd like to use it. That's going to do it for section 9.4, and that's probably going to do it for the course. So we'll see you another time. Take care.